We're here at the University of Nebraska in Lincoln with Mike Arthur, the Director of Strength and Conditioning at this university. And I've known Mike for years, and it's just an honor to sit down with him this afternoon and talk about a subject that really kind of is the backbone of our institute, the Postural Restoration Institute, because the principles that we use in this model not only guide us in terms of how we put our course material together, but our philosophy behind the use of the glutes and the hamstrings and the muscles that keep us supported in day-to-day activities. And this model, ever since he showed it to me about a year and a half ago, Mike, has just captured my interest in what he has done, both with his career professionally, but what he has done with this model has captured my interest in what he was intending to do with this model, because it reflects so well the concepts that we believe in PRI. So my interest in this, Mike, was escalated the day you showed it to me at a talk we gave this last year, I believe. Was it the strength and conditioning?
Strength and conditioning, yeah.
Yeah.
That was the,
He pulls it out. We're halfway in the middle of the presentation. Mike pulls this thing out. First time I ever saw it, and it really was cool. So Mike, thanks for doing this with us. And what I'd really like to have you do is maybe relate your scientific thinking to this model. And what the model does for students is gives them a visual description of what we see going across two joint muscles, muscles across the hip, muscles across the knee. And in this case, you add another joint in there, and that's the ankle. So why don't you talk a little bit about the thought process you put into this model as it reflects your thought processing and what goes on here at the university with strength and conditioning.
okay, well, it started off, like you said, by articular muscles, and I always wanted to know how they worked, and I decided to make a model. So basically what we have here, 4 segments, 3 joints, and it's the hip joint, the knee joint, and the ankle joint. It only works in one plane of motion, the sagittal plane, but squat's primarily a sagittal plane muscle. But reading the research on it, they always talked about the biarticular muscles really don't change length, so I thought I'd test that premise out. And the muscles here, as you can see, because they don't change length, they're made out of polycord, so they don't stretch, so it doesn't do the normal stretch shortening cycle. So it turns the muscles where they're almost in an isometric contraction where they don't change length, so it's kind of like a tow rope where I'm pulling a car where it doesn't change length, but the mechanical energy is transferred throughout the body.
And I think that's probably one of the first places we could start off with, is that you recognize that when you read about muscle contraction, muscles that go through a contraction, we often think there's a concentric muscle philosophy, and it's an accurate one. When you contract a muscle, 2 ends have to come together, and that muscle shortens. If it's a 2-joint muscle, there are joints that take up that contractility, if you will, but really the length of the muscle isn't probably really changing as much as one thought.
Right.
So that word concentric on a 2-joint muscle, depending on how it's being used and what form and what position you're in when you use it, can have actually a positive influence on a neighboring joint or its bi-joint, the joint that works with it, without really concentrically contracting as much as one thought.
Right. So I guess what's interesting to me about this is that all 3 of the joints cross the knee joint. So that I feel that makes the knee joint a very important
So repeat that
joint.
again, all 3 of the joints.
All 3 of the muscles cross the knee joint, the gastrocs,
I was going to go over that.
the rectus, and the hamstrings.
So the gastrocnemius, the vastus rectus, okay,
Right.
the medialis and lateralis is the rectus, and you got your your hamstring, obviously, that crosses both the ankle, knee, and the hip.
Right. And I think what's interesting is that most people teach to bring the hips back, but I think if you take the knees forward, bend at the knees, you have to bend at the ankles, you have to bend at the hips. And
Otherwise,
vice versa, I could bend at the hips and not have to bend at the knees, especially if my foot's on the ground.
Right.
So if I take this muscle and I'm in the standing position and I just bend at the knees, I have to bend at the hip.
So you're getting flexion of the ankle, that's called plantar flexion, flexion of the knee, and flexion of the hip.
Right.
All three have got to happen.
Right.
So in that position that you're in right there, if you only move into flexion in one of those units, then that muscle could be going through a contraction state where part of that muscle is actually shortening. In other words, one muscle shortening, the other two joints are being pulled together or pulled apart, if you will, an extension, and you don't have all three joints flexing at the same time at that time.
Right.
An example of that would be, let's just take the hamstrings. If I contract the hamstring with my knee in this flexed state, all I would get is that knee would have to lengthen across the front in order for that to happen. In other words, if I just sat there and pulled my hamstring in, I would not be able to theoretically pull my hamstring in and extend my hip if my quad did not co-contract at the same time.
Right.
If my quad did not co-contract at the same time, I would be lengthening that quad in a non-desirable way, putting undue stress on that kneecap, resulting in patellofemoral pain, tendonitis, or something going across that joint because that knee was not extending at the same time that hamstring was extending that pelvis. Is that correct?
Yeah.
And I think that's a source of a lot of our knee discord, a lot of our pathology of our knees. We forget the fact that when you're going into extension of the hip, you have to be also going in extension of the knee and also extension of the ankle. And if you don't, there's going to be undue stress across one of those three joints. I mean, that's fairly comfortable. You're fairly comfortable with that.
Yeah.
Okay. When you looked at this tri-joint issue, Mike, with somebody who is squatting, going down, not going up, going down, over the years of doing the work that you do here at the university, how did your thought process change the way you direct students to lift? How did this thought process change over the years?
Well, I think one of the big things is that instead of trying to hold the stability with my back muscles, I wanted to use my hamstrings to provide the hip stability. So instead of, I think one of the big things I quit doing was stretching my hamstrings to keep my hamstrings in a good position to work with the rectus. So for instance, I think most people want to squat with a more upright trunk. So the only way that I can do that is to have proper length between these two.
Right.
So if I lengthen, I can do this. If I lengthen these hamstring muscles, the only way that I can keep is that's going to let my trunk come farther forward.
Correct. So the more...
And then I'll have to take that up by tightening
the quadriceps.
The quadriceps, and then that's also going to put more pressure
across
on the knee and the back. So
right.
If I shorten the hamstrings here, let me straighten it up, shorten it up a little bit. Then you can see I can keep my center of gravity with the more, I didn't get quite it.
With less demand on that quadricep group.
Right. And
So,
also the back, I feel.
Correct. So philosophically, you knew the more that I generated power from my hamstrings for either squatting or coming out of a squat, the less demands I put on my back extensors and my knee extensors.
Right. So now you can see I'm more
Correct.
upright there.
Yeah.
But I guess at the same time, though, it lets the knee come a little more forward, but I think a lot of strength coaches have a problem of where they think that puts pressure on the knee. They don't want to bring it from the toes, but actually I feel you're getting more stability.
And that's actually why I was so excited to see this model, because the first time I ever saw a model that would teach a student the importance of the knee going forward to reduce quadricep demands. Because when that knee goes back, the extension needed for that knee to come back through the quadricep puts a lot of pressure across the front of that joint via the patella. And it's difficult for people to understand that without seeing that three-joint model that you put together, in my mind. I wouldn't know of anybody else that could demonstrate that better with those two or tri-joint or bi-joint muscles working in a contracting way, but at the same time not losing attachment site length to the muscle.
Right, right.
Tell me a little bit about, Mike, your thought about hip. We use the word acetabular femoral rotation a lot. We use the word acetabular femoral flexion or acetabular femoral extension, where the pelvis is actually moving on a femur, not the femur necessarily moving on the acetabulum. In strength and conditioning mentality-minded people, they think about hamstrings pulling the femur back on the hip. But I know this model reflects somebody who's actually pulling an acetabulum back on a femur. Maybe comment on a little bit about that. The pelvis that's being pulled on the femur by that hamstring.
Right. So basically the hamstring back here is attached up here, so as I let it down, it's pulling this way.
Towards the table.
Towards the table.
Correct.
Which controls the trunk
so the
going forward.
The trunk has to go into flexion for that pelvis to go to that table.
So this is moving on this here.
So the trunk is going into flexion and the pelvis is going into extension. That would be acetabular femoral extension. But that's with respect to the femur. But with respect to the thorax, it's actually going into thoracolumbar flexion. So the curve in the low back isn't getting deeper. The curve in the low back is actually staying in a neutral state. Whereas a lot of these athletes, if they don't have good acetabular femoral extension, they stay in a lot of lordosis, a lot of thoracolumbar extension, which is lordosis. And at the same time, they then lose the ability to bring their knees forward and the pelvis back. So another concept that I think is really neat with this model, Mike, is you demonstrated to somebody who is worried about compression of those joints, specifically in the posterior segment of the low back joints. You can reduce that by keeping this model alive, by bringing the knee forward and the pelvis back. You preserve integrity of that low back. And I know that's difficult for strength coaches to get. It was difficult for me to explain it to strength coaches. That's again why I was so excited about that model.
Right, and I just know through practical experience of doing that and realizing that I have fewer back problems now.
Because you decompress that lumbar spine, but yet you don't lose power. In fact, you gain power from this table, from the floor that that individual's sitting on, because all those muscles that go across those three joints have a uniform effect, an integrated effect on the lift that's going to be generated from these feet through the knee and the hip without just sacrificing lift from the back.
Right, and it also positions the glutes in a position to where it can actually
good power.
Right,
good power.
Where it can be underneath, where it can push
extend that hip. Extend that hip.
Right.
Push versus pull that hip up into that position.
Right.
Hip flexors are pullers. Hip extensors are pushers. And again, with this model, I think you can demonstrate that if you really want to get somebody to be able to push up and forward, the knee has got to go forward and back. Right.
Right.
Ankles have to be able to, at the right moment, flex and extend for that to happen, because it's all one polyarticular chain of muscle that allows you to do that. A couple of things that really caught my eye, excuse me, and made my mind work a little bit was the actual demonstration of what's going on with respect to the lower, the tibia and the thorax itself. They're actually kind of parallel with each other if you look at it.
Right.
And you can lengthen or shorten this muscle tension to get even more of a parallel activity. If I go up with this, you can see, if you hold that down, Mike, look at the parallelism going on between the tibia and the lumbar spine. Do you want to talk about that a little bit? Comment on that a little bit? What's going on with, think of the skier, or think about that person going through that early phase of jump or that late phase of land. The low back has got to be going into a direction where it's got to be coming forward to complement the need for the tibia and the low back to stay in a vector that's not putting one at more workforce demand than the other.
Right.
So when I look at that low back and I say, okay, I'm going to land, Mike, I'm going to land. If I land and I don't let my knee come forward, then my back is going to stay extended. And now all the movement that's going through that land has got to be broken up by a quad, because it's in a state of too much extension.
Right.
To get that quad to let go and reduce the tension on that knee, it's best to let the tibia move which way? Forward. So the back then has to go into thoracolumbar flexion. Would you agree?
Right.
So tell me a little bit about the way you translate that information out there to the floor when you work with a person that's going through a strengthening program to strengthen up quads. You want to strengthen up quads by having the quads go through a moment of flexion and a moment of extension. This is a moment of flexion. This is a moment of extension. Under each moment, the low back and the tibia are staying parallel. Right? And so how do you carry that out on the floor? What do you do on the floor? What kinds of positions do you put your athlete in to reflect this model?
Well, I think big part of it starts with the feet, and I try and get the feet to go more forward. I know a lot of strength coaches want to get them really out wide and abduct at the hip at the same time, but I think you can get motion at the hip. If the feet are forward, then you're going to have to dorsiflex more in the ankle, which will help you get that motion in the hip then. And then also you're using the gastrocs to control the knee as you go down forward. So I think a lot of people want to do a lot of gastroc strengthening, but you actually want to stretch them so it allows and controls the knee going forward, and it's working with the quads to get that stability in the quads, and you can use the quads then and the gastrocs to help decelerate
or
accelerate knee extension or knee flexion. So
via that gastroc joint. It's an important concept. In PRI, Mike, you know that we really believe that you can't stay neutral with function to actually develop coordinated control and core strength if you don't have these three planes organized in a way that allows your neutrality to stay throughout the entire process of the demands you're placing on that body. The first thing you need to have is this sagittal definition, this sagittal moment coming from the ankle, which you just went over, which begins really truly, if you think about it, the gastrosoleus complex. It actually ends up with a muscle called the lat. The lat is a muscle that extends the back. The gastrosoleus muscle is a muscle that extends, if you will, the ankle. Okay, that plantar flexion, or that extension through that ankle, then generates all the way up into the back as this knee is transformed into what I would call an extended state. As that knee is going through that extended state, the gastrosoleus muscle has to do one thing to that femur that it attaches to: pull it back. And if that femur does not come back, the hamstrings and the glutes can't do their job to get that hip to extend. If that knee isn't pulled back by that gastrocnemius muscle, the demand on that lat for extension goes up. Key concept that this model demonstrates. So if you have a lat up here that is now working hard because you forgot how to use the floor to push your toes down into, to generate forces on that knee to come back, you can't move anything up at that point without overextending your back. Do you see that often with the weightlifter?
Yes.
Overextension of the back?
Just coming right out of the bottom, their hips will tilt forward and their back will come in extension, and then they'll lose their back muscles basically.
How many years of experience do you have working with people doing lifts, improper lifts, and people who are doing proper lifts? You see all forms.
Well, I've been doing it for about 40 years now, and I'd say I've been teaching it wrong for 25 and teaching it right for 15, and the athletes, not only do they have fewer back and knee problems, but they can squat more. They have more power.
And control. And the demand on the other two planes, the lateral plane and the rotational plane, the X plane and I believe it's the Z plane, is the demands go up on that athlete. So torsional demands for control can be reduced if this particular plane and the cardinal rules that go with it are established and maintained. And I think those last 15 years you realize that.
Right.
Otherwise, what you have is the other planes trying to do something for that sagittal plane in a torsional way, with actual if you will, malconcentric activity, almost pathological concentric activity on one end of the muscle, and not enough of activity going on the other end of the muscle because of the lack of that 2-3 joint principle that we went over earlier. And do you see that as one of the reasons why people do hurt their backs, if they do hurt their back lifting?
Yes.
So that's made that.
I guess another huge thing, I mean, right from the beginning that I learned from you and it didn't click right away, was to breathe and use your abs to exhale, to contract your abs and hold your pelvis and rib cage in the position to give you more support.
What does that do when that happens, when you get that trunk stability provided by a respiratory function, exhalation? What does exhalation do for a person in that model? And what would lack of exhalation do to that model as you lift?
Well, the exhalation helps keep the trunk in a slightly flexed position because it pulls the rib cage down.
Right. And
your abs are spinal flexors.
Right.
But at the same time, it's keeping your pelvis pulled up in the front, and then
which is a posterior pelvic tilt.
Right, posterior pelvic tilt. So it keeps your hips level as you go down and up.
And once again, not to cut into your message, once again, enabling the lumbar spine to stay parallel with the tibia.
The tibia, right.
So the other complementary muscle force going on at the same time would be the muscles that extend that lumbar, lumbar pelvic femoral complex. That's your hamstrings,
right,
and your glutes,
hamstrings, glutes,
all right,
abs working,
abdominals. So when you work with a player who is now losing the ability to maintain a neutral lumbar thoracic joint or a neutral lumbar thoracic spine, you could then say to that athlete to get that without subconsciously, to get that activity to be performed correctly without inducing pathology or activity with concentric and eccentric design muscle, to reduce all that subconscious wrong, you now know that if you have them lift as they exhale or as they extend their hip, they're also going to be lifting in a way that's going to require a knee to go forward or a knee to go back. And I think that just being around some of the coaches and the trainers the last few years, I think that's a real difficult concept for them to establish. And I don't think it's because they can't understand it. It's hard to understand how that knee can have such an impact, or that ankle can have such an impact on that hip and that lumbar spine.
It's just kind of the way you got your education growing up, and then coaches just teaching, because it just kind of makes sense. If I tighten my back up, it's going to straighten my trunk, but it's actually the opposite of what's happening unless you try it and experiment with it, put it into practical terms and feel it. Then you're going to realize that I've taken a lot of pressure off my back. I've taken it off my knees, and I've developed more power, more force capability.
I call this an isometric model, Mike. Somebody saw it on my desk the other day. I know you were kind enough to let me borrow or even have it, but I was sitting on it. It sat on my desk since you came.
It's got your name on it.
Does it really? Where's my name on this big? Is it on there? Okay. But anyway, it was sitting on my desk, and we had a student that came in. Joseph came in, and he said, "Who built the isometric model for you?" I said, "You know what, Joe? You're right. That's an isometric model. It's not moving. But yet, for it to be in that position, there's a lot of activity going on. And that activity is balancing that movement. So now it's inertia. Inertia is at a still point. And that still point, I know you can eloquently hold it up here, or you can hold it down here. It's isometric. It's an isometric concept. Why is that important for isotonic activity?
The first thing that comes to my mind is it helps conserve energy.
Bingo. Less work.
It's
for more, less work for
less
more activity.
Fatigue, and
less fatigue.
you
can rest
you
here.
do this. Yeah, you can rest in that.
And
position.
I really never really thought of that until that student said, "Well, you know, that means that person can actually stop, and actually sit there and breathe and recoil and relax, regenerate, just all the R words, restore." And as you're in that isometric state, whether you continue to go down or go up, at any moment in the point you stop, you're safe, because you've got all those vectors in a position where they're all depending on each other to stop without pull, without the need to overextend or overflex somewhere in that polyarticular chain muscle that you shouldn't be working or shouldn't be stretching to the degree you are. Would you agree with that?
Yeah.
So that's what really excited me also when he reminded me that's an isometric model for an isotonic form of activity that's going to occur if you're going to do it in a correct way. I thought it was a brilliant, insightful comment. A couple things I wanted to bring out with this model that I always think is important, for me anyway, in a simplistic way, is the importance of the hamstrings and what they do to, when I start off in my career, the hamstrings were a muscle that nobody really looked at. Hamstring co-contraction with quadricep development back in the 70s and 80s was really, the industry in isokinetics was all about that. And to this day, isokinetics is still one of the safest ways to rehabilitate a hamstring and a quadricep muscle safely. Speed is a driver of strength. We have to do things fast. To do things fast, though, joints have got to move into positions so that speed doesn't tear away an attachment site, or tear away fiber from an attachment site, or tear away the fiber itself. Speed is really important. And so as I look at this from an isometric standpoint, and then I move it into the isotonic world, I think about the next world, isokinetics. You got to be able to move quick. I think the explosion that comes from these three muscles really needs to begin with a vector of reference, and that is the thing that your toes feel, the heel feels, the arch feels, and this piece of wood right here is all about, the floor, the force vector, the reference center. How does that translate up, Mike, into what really has to happen? Extension, drives people forward. Flexion puts you in that position to safely do it. But generate that activity for me. When you're working with athletes who need speed, they need power to develop that speed. Speed is based upon a reference center. In this case, the reference center is this foot. Take me through that. What would need to happen for an athlete who's now going to generate a heel that's going to come off and the force is going to go on that toe? Take me through that process and then tell me where that speed that you guys are looking for, that speed that you have to have from a hip that's pushing the femur back, that's back in the 70s. Femurs extend on hips. But what you've got a model here is you've got a model that tells me pelvises extend on femurs. Take me through that concept.
Well, you were talking about the vector, so basically that's the gravity line.
Correct.
Right?
It's balanced right through that middle.
Right, and it balances through each of these segments and these muscles, how to find that balance within that. So basically you're talking about running and moving forward.
Propulsion.
So basically you got to bring your body or center of mass forward in front of that vector.
Just demonstrate right there.
Right there.
So now the contact point is on the forefoot. Now when that forefoot starts to push on the ground, what did that do for that individual above that reference point? Inherently, it did what? It had to
extend.
That's the word.
And
extend.
And something that helped it extend was gravity.
So you use gravity. You use gravity to help extend a back without overextending the back against gravitational forces.
Right.
You pushed it. Yeah. How did gravity help that?
Well, each of these have got to kind of hold it in place, but if I just let it fall forward, it wasn't me doing that.
The brain sensed this gravitational force on us. Thank God we got it right, Mike.
Right.
Otherwise, the brain would not know how to keep that body in a position without you going into complete malalignment, without power.
Right.
You just lost every vector when that happened. I know a lot of people that they get out, they walk with a leg that is too what? Extended. Because they lost the ability to figure out how to use gravity.
Right.
How to use it, not how to fight it. Would you agree?
Yeah.
So they're overextending the knee.
And they're
wasting
wasting
the
energy.
back.
They're always tired.
And they're pooped.
Right.
They're chronically tired. They get fatigued out fast. Speed can be a factor on that.
Well, these muscles also work in the swing phase too, and the speed of the leg swinging forward has got to be twice as fast as the foot on the ground.
Explain that to me. I'm not sure I understand.
Well, I can take this off the ground and I can still. It still works.
In an open chain.
It's open chain. So when my leg is, after I'm on the ground and get extended, now I got to bring it into flexion.
To strike that ground again.
And come here.
Push down forward.
Flex. So it keeps working over and over, and these muscles all work together through that open chain and closed chain.
So regardless of whether or not you're pushing off the ground, regardless if you're going to the ground, to find the ground,
right?
It's the same.
Right. These muscles coordinate that whole action.
Right.
Without actually changing length.
All you got to do is keep the pendulum.
But
moving.
if you train the muscles to where the right length in the muscles is preserved, then you're going to get the correct positions in the joints.
Without a lot of effort.
Whether it's closed chain action or open chain action.
So let's get back to the word isokinetic. So isokinetically, as your speed is increasing, the same isometric principles that we saw on this table are carried through that speed-driven process.
Right.
And I think a lot of people don't understand that.
Right.
They look at isokinetics as a one-joint issue, and it's never going to be a one-joint issue.
Right. There's a lot more going on So I know the argument used to be closed chain, open chain machines.
But if you're really a system person, if you're really a system thinking driver, you're one and the same. Because in order for you to reciprocally move, that open and closed chain is never going to be impacting one end of it, so that you're always in a closed chain. A lot of people believe you got to stay in that closed chain to keep people strong. And you just said, oh well. You got to get them out of the closed chain, into an open chain, back out of the open chain, into a closed chain. Otherwise, you can't facilitate that reciprocal.
Actually, you probably spend more time in an open chain movement.
You would hope so. And then
especially in sprinting.
Exactly. For speed.
For speed.
Right.
It's more of an open chain, and those muscles have to be in the correct position.
So here we are, we're discussing this isokinetic speedster that's sitting in front of us, that's going to be going through an isometric closed chain strengthening program. And I'm looking at you, Mike, and saying, I'm not a 110-pound athlete. I'm almost a 200-pound athlete because I'm not even an athlete. But if I were going to try to run faster, and by becoming a smaller framed, speedier type thinking-minded person, I still would have to be going through some closed chain isometric principles to make sure that those joints are moving correctly together for open chain speed.
Right.
Is that correct?
Yeah.
I think that's an important item. I really do. And it's not even for power, it's for efficiency. Right? It's training those vectors to work together in a manner that's one thing's preserved. Thoracic flexion with flexion of a knee and flexion of an ankle, isometrically. And as you start to come out of it isotonically, you still preserve those joints working together harmoniously at the same time. So extension, extension, and extension.
Right.
If that's preserved, no matter how fast you are, you shouldn't disrupt the chain or cycle of events that keep that polyarticular chain regulated by itself, antagonistically, agonistically, by itself. Would you agree? In other words, in the sagittal plane by itself should maintain. I think that's where finally the programs break down. I think programs break down because, Mike, we generate a lot of philosophy on a hip when it goes bad by working hip muscles, on a knee when it goes bad by working knee muscles, on an ankle when it goes bad by working ankle muscles. Instead of doing this, on all three joints when the hip goes bad, and all three joints when the knee goes bad, and all three joints when the ankle goes bad. You don't know it, but you're treating and training word isn't mal, but I would call pathological states and conditions that I see. Your philosophy works better in my program of working with those patients that have a lot of problems, real generated problems, by not isolating one joint to get them better, but really isolating the sagittal concept of isometric function, isotonically and isokinetically, without losing those principles that we just went over. And now they'll get better faster because they're not only concentrating on one joint. It always kind of bothered me to see somebody just do knee raises with the hip, or quad sets only with the knee, because there was no tri joint perfecta going.
Right. Well, I think a lot of strength coaches now to train the hamstring use RDLs, which you just said may not be the best way to train hamstrings. Is actually you're strengthening the hamstring in a lengthened position and strengthening one joint, the hip extension, which most strength coaches think is important, but it's the combination, it's the integration of all three joints working together. So I don't want to train the hamstrings in a lengthened position at one joint.
As a biomechanical consultant for the university over the years, I have seen your injuries go down, I believe, in the lower extremity and low back because of that principle you guys have here at the university. And I know that's spread out in a lot of programs. everywhere from your softball, volleyball, and football players to your track players and your baseball players. And I know over the years, Mike, you had a lot to do with that. How difficult is it yet to this day to get an athlete to understand some of these principles? Is it getting easier and easier for you to do that kind of activity?
Not really, but at the same time, because they've been taught the wrong way in high school, and then they come here and I teach them a completely different way, so it kind of throws them off. But within a week or so, they start, they actually, my back feels better, my back isn't sore anymore.
And that's when they become
and then they become a believer in what I tell them. And then I can take them through, show me how to take athletes through ranges of motion. So if I pre-test them, show them the ranges of motion of rotations and so forth, internal and external, or just hip extension through that Thomas test, and then put them through a squat. I can just have a person squat down to a chair with no weight on, just holding, exhaling, and hold their spine in the correct position, bend correctly, and it'll straighten them out. And then I can take them right back and show them in an extended, just doing squats with no body weight, but holding their back like they've been taught. Take them through the ranges of motion again, and they're back to dysfunctional, losing their ranges of motion. And then I can take them right back.
Show it to them.
And
So you go
within
back
5 minutes, I can go back and forth
showing
and
them
do
that,
the
yeah.
test, and then that converts them right away.
Well, honestly, this plane of activity we're talking about this afternoon, if it's not preserved, will only result in pathology or malactivity or improper activity in the other 2 planes. The frontal plane, your adduction capabilities, or your lateral transfer of weight through the ankle laterally,
Right.
or rotational activities with the spine and the hips, specifically, that you'll see a reduction or a gain in that you don't want to see. And all because they didn't follow the law of what that joint activities got to carry out to maintain proper neutrality with mechanics that have to be isometrically understood for, again, that functional activity to occur without generating undue stress across one of those 3 joints. You know, Mike, I got to tell you, I really appreciate all the work and effort you put into teaching students over the years that I've been around you. This particular model is just one of the best examples of the way you think. And again, congratulate you, and it's brilliant. I look at it and I think it's a great way, it's a great tool for people to teach someone how to lift correctly, but more importantly, on how to get into a state to lift. Which I think is one of the biggest misconceptions out there. To be a lifter, to be a person that builds strength, once the process is started, that's where all the function is really developed. But really, you have to establish the form first, and I think this model does that. Is there anything else about the reasoning behind your thinking for this application, or the way you apply this application, that you'd like to talk about before we adjourn?
No, I think I made it to show the simplicity of it. Once you can see it with your eyes instead of most biomechanics is done with lots of technology and high-speed cameras and EMGs and.
But the simplicity of the system.
But the simplicity is shown
before us.
Right here without going calculus. So I think that was the main thing, is to get the point across without it being a complex situation.
I think you've succeeded. Thank you very much for letting us come by this afternoon, Mike, and interviewing you. It's going to be meaningful to anybody who watches this and understands this model. And I think it's more important, it's nice to have you actually explain the reasoning that went into it and the reasoning of why you think it's important to at least keep it simple and not complex. Thanks so much, Mike. Thanks for your time. Thank you very much.